Okay, so this next problem, one of the first things that you realize is that we're working with a field of view problem here. And so we need to identify again what our Riverstone microscope's field of view is. You guys should have calculated this in your microscope station work, but remember that what you're going to do is the field of view formula to translate it to a high power measurement. So you have to start with the diameter of it in a low power. And remember, that's because once you zoom in too much, you're not going to be able to see anything of significance for the field of view on that measurement. And then you multiply the diameter of the low power times the power of the objective. And in this case, we're still working with the low power objective. And then we divide that by whatever objective we're trying to determine the field of view for. In this case, it's asking us for, where we've looked at it under high power, so we need to know what the field of view is under high power. So the power of the objective in high power. And that's going to give us the field of view in high power. Now, just for reference, in case you haven't gotten to the station yet, the diameter of the low power objective for field of view is 4 millimeters. And we could go fancy and get 4.5, but we're going to stick with 4 for right now. Times the low power objective. If you remember, it's 4 times plus the ocular, which is 10 times. So that's going to be a 40x objective. We're going to do that 40x divided by our high power objective, which is 400. Oops. Not HB, but HP. So with a little bit of quick math here, 4 times 40 is 160 over 400. We're going to get a 0.2 millimeter, or I'm sorry, 0.4 millimeter field of view. Got ahead of myself there. So 0.4 millimeter field of view. And then in my problem, I said that it is observed to be about half the field of view. So half the field of view, half of 0.4 is 0.2. So what's that telling us, right? That's telling us that our image size or our actual, right? Our actual specimen is approximately 0.2 millimeters. And we said that the student draws the cell to be 25 centimeters in length. Well, here's where we want to come back to that unit conversion, right? We want to convert 25 centimeters into a matching unit here. So we want our image is 25, right? Yep, 25 centimeters. So I'm going to convert that to millimeters to match this so that we can have cohesive units. And so that's going to give us 250 millimeters. And now all that I have to do is I have to think about my, my fancy little triangle, right? So M times A all under I. We're looking for what the magnification of that drawing is, right? So how much bigger is that drawing than the actual organism? So we're going to take our image, so 250 millimeters, divided by our actual, which is 0.2 millimeters, and that's going to give us 1,250 times. However, think back to our problem, right? This number, the actual number, this was an estimate. So we can only use one significant figure here. So we're going to go to 1,300 times will be our answer. Okay, and we could even go down, honestly, you could even take it down to 1,200 could be acceptable as well. Okay, so there's kind of that 100 times range there.